And then I already got this class on YouTube, but not with the Alex, and I did it during the summer when the classes were real long, twice as long. But anyway, you click on learn, and that gets you back to it. You don't have to worry about any of these other things. You know, you can go to the grade book and see how you're doing. But I want to try to use the Canvas grade book if I can get everything to import successfully. It's supposed to do that automatically, but we'll see. There's a calendar in there. I don't know why you would need that necessarily, but it just kind of shows you the breakdown. But anyway, that's how Alex works. And like I said, is and then when you get to a certain topic, you get these little things filled in here. You know, they'll like throw some confetti or something up in the air, and you'll get that little piece of for your pie to fill in your pie. See this? Because I skipped a problem, or in the same case, if I had answered it and gotten it wrong. But I remember skipping through this. So, see, they're going to keep it in my view because they want to make sure I know how to do this. So, hundredths is this is ones, tens, hundredths. So, we got to round to that number. So, the one needs to be rounded. And since the one to the right of it is five or above, then we bump this up. If this had been less than five, then we would just chop it off. But anyway, I mean, the benefit of doing it in the what happened? Oh, I'm sorry. I know what I'm doing. Hundredth is okay. It's ones, tenths, and hundreds. Ones, tens, hundreds, thousands. So it's 1, 9. There we go. There we go. So I got one correct. So then I do it again. And now there's another one. So I'm going to have to get a bunch of these. If I had gotten it right on there, it wouldn't be in my path. But they want to make sure you know this because a lot of statistics is simply rounding and people don't round properly. So the nearest tenth. So this is tenths right there because the zero is the units. And then on the other side of the decimal is the tenths. So this is 0.3 because the number right after the 3 to the right is less than 5. Nearest whole number. Well, the nearest whole number is over here. So we look at the 4, which is the units. The number right to the right is below 5. So this is 74. See now, I got them all in a row. So they're going to give me credit for it now. All right. But I've knocked that out. I'll never see any more explanation now, or they'll never ask me directly to just round off a number. Now, you may be asked to round off a number in one of your problems because it says calculate the probability and rounded it to the tenths. Then it's expecting you to remember how to do that. All right, so I'm not going to belabor all this, but see, like I said, is I had skipped some of these, so I'm still seeing them in my. Because I'm going to just briefly go over chapter 1 and assign that to you to read and do that. And there's not really a whole lot to it. But there's bunches and bunches of pop-ups the first time you go through with it. So anyway, it's still asking me because, like I said, I didn't answer these. And like I said, there's no shame in if you didn't know it because it wants to find out what you really know. Well, you know what? There's a calculator over here. This calculator. because it's putting the calculator. I mean, I don't know how you get rid of that little bar for the zoom. So round to the nearest tenth. So this is tenth, so that's 2.2. See, and it's going to go back through the same thing. So depending on how much you didn't get right or answer in your view, I'm sorry, your knowledge check, you're going to see them. They've got nothing to do directly with the course, but you got to get through these first. So that's why I would say if you know how to do them, then do them right in the knowledge check, and then you won't see them anymore. But they're going to keep popping up in here until you get them right. All right, so that should be enough. I mean, this is going to be the same thing again because I want to get and go. I just want to make sure that you kind of got the gist of chapter 1, and then I want to get it can let you out a little bit early today. Nearest hundredth, so that's 1.09. See, and you can even hit on explanation. See, and because I got the 3 in a row, then it gave me a little bit of bump of +2. But this is how Alex works.
I have a question.
Mm-hmm.
So, like, let's say you don't keep getting, like, you get the question, but you don't know how to do it, but it keeps giving it to you, obviously, because you're not getting it right. Does
Mm-hmm.
it ever give you, like, an
Look,
explanation or, like, a
look at this. Watch
how-to?
the screen. It's hard to show because, well, I don't know if you can see it or not. Because that zoom thing, no, you can't see it on here, but see that right there?
Um,
Explanation.
oh, yeah.
So, yeah, let's proceed to it just to show you. See, that just tells you the process.
Oh, okay. That helps.
All right, let me just knock off this last one so I can get my little credit. This little thing is in a way. But I mean, it doesn't show up on the view, but I mean, on your view, but so this was nearest hundredths, so tenths, hundredths. Seeing if I do one more. Nearest tenth, so that's the tenth, the 8, so it's 0.9. See that? So that's all there is to it. And like I said, is once you finish with the prerequisite things, then you'll start seeing the things related to what we're going to go over. The chapter 1, I'm just going to hit it real quick because it's not a whole lot to it. And I'm going to have you mainly just look at it on your own. I guess I'm going to have to download it. I thought I had it in here already. I just want to kind of hit on a couple of things that are important in that. But I've got the PowerPoints here. And those PowerPoints more or less include what's the important stuff from the textbook. So chapter one, it just kind of gives you a bunch of definitions for the most part. There's not really any kind of calculations or anything like that. But I'm going to show you and just take you on a whirlwind through this. Most of these things you're going to be able to learn by just doing the online work. But I'm going to hit the things that are important so that sampling is something. It's not very easy to do, and we can kind of construct a whole class about this. But the goal is to have a simple random sample. And so throughout the course, you're going to hear that over and over. Assume a simple random sample. Now, the book does go through several different ways to do it, and that's fine. You can read about those. But for the most part, it's not really something that it's really beyond the scope of this class about how to actually do it. They just tell you about varying methods of getting a random sample. But statistics is just basically how the study of collecting, describing, and drawing conclusions from data. Now, Math 120 and this in the first half of this course are basically what we call the descriptive statistics, because it's just calculating things. But the drawing conclusions part is what we're going to look at in the second half of the course. Now, a population is an entire collection of individuals that we want to study. But most of the time, all we have is a sample, and that's why that sample has to be representative of the population. And that's why you've got all this about how to collect a sample, because we want to make sure that it represents that population. Because the population can be very large, and you don't want to necessarily have to work on that whole population if you can just work on a sample that represents the population. So the best way to kind of describe a simple random sample is with the idea of a lottery. Most people kind of know about that. And if you are playing the lottery and 5 tickets are sold, then you would want those things to not be biased in any way when those numbers are picked. Because if there's some kind of bias that somebody's picking numbers that they know their friends got, or somebody that has got some kind of a rigged game, then that's not exactly what we're looking for. We're looking for a fairness in the selection of that sample. And it's very much like a lottery, because when you have a lottery and the person goes in there and chooses that first number, it should be chosen completely, entirely at random. All right, let's go up here. I'm not going to mess around with talking about the different kinds, because, but let me mention this. The reason why this course is called statistics is, for the most part, is because we're calculating on samples. In the rare occasion when you actually have the entire population and you calculate something, it's called a parameter. All right. So that's just what those two things mean. Statistic belongs to calculation on a sample, and a parameter is one from the entire population. All right. I want to show you one particular thing. Okay, there's two types of data for the most part: qualitative and quantitative. Qualitative, essentially like quality, that's where that word comes from, and quantitative comes from the idea of quantity or amount. Qualitative is when we classify data into categories, but with quantitative, we can usually tell how much of something is because the data is numeric. And I just want to bring this up because this is something that you're kind of going to see throughout here, especially with quantitative data. But quantitative data, a person's age is quantitative, but a person's gender is qualitative, because this is a number, because it represents, how long this person has been on Earth, whereas this just is just a quality of that person, male or female. The mileage of a car, that's quantitative value. But the color of a car is qualitative because it's different categories. Nothing numeric about it. Now, within the two types of qualitative data, I mean, within the category of qualitative data, we've got ordinal and nominal. And these things are just kind of naturally occurring, essentially. All right. But if we kind of think of things like first, second, and third place, those are qualitative values, but they have a natural ordering to them. So they would be an ordinal value. But if it's something like male and female, there's no real order there. They're just both descriptive characteristics, and they don't have a natural ordering. So nominal, it's just like a name. That's all that means, name. Nominal is name. And I'll take you through this really quick, and that's probably all we need to look at. So classify ordinal and nominal. The variable is nominal. The state of residence is nominal because it's simply just a name. There's no natural ordering to the states. Same thing with gender, as I mentioned before. There's no natural ordering. But look at this, letter grades. Everybody knows what's more desirable there than the other one because these are ordered. Best, next best, average, a little bit below average, and below average. Size of a soft drink. Now, I don't ever see small anymore. It's usually like medium, large, and extra large or something, or jumbo. But still, the idea is the same. Is those are naturally ordered. All right, and then the other one that I want to mention is the difference between discrete and continuous. These are both numerical. These are both quantitative, but we need to understand the difference between them because these are going to dog us throughout the semester. If you've got discrete variables, then that means that all the possible values can be listed. If we've got continuous, then what that means essentially is, and you may have not thought about this, but if you look at a number line between 0 and 1, there's actually an infinite number of values in between the two whole numbers 0 and 1. 0 and 1 are discrete values. But in between 0 and 1, we can always find another fractional value. And that's why anything like that that's written generally with fractions or decimals is called continuous. So let's look at an example. And then we'll be out. I'm going to, like I said, I like to give people a little bit of time off of the first. Age of person at his or her last birthday. Now, most adults don't do this, but I know the kids will kind of say things like, well, I'm 6.5 or 3.5 or something. But usually the way that you measure age is the age of a person at their last birthday. That is guaranteed to always be a discrete value. If you were to give their age in number of years decimal wise, then you could say, well, she's 26 and 0.3567 or something like that. And that would correspond to a certain day and time on the calendar. That would be the difference between continuous and discrete. Discrete is always going to be a whole number. Now, the height of a person, if you've ever seen a ruler or a tape measure, there's a bunch of little values, and I think there's usually 32 of them in between each one of the discrete whole number values. So if you're measuring in height, person's not going to go to just 1 inch to a particular inch marking. They're going to go at some point in between, and it's going to be a fractional amount. So that's continuous. The number of siblings a person has, there's no way that that can be partial. It has to be a whole number, so it has to be discrete. And in a distance person commutes to work, if you've ever looked at your odometer or reset before you go to work, most likely it's not going to fall on a whole number. It's going to say 32 and 6/10, because that's usually what the odometer measures is tenths. All right, I think that's probably what I'm going to look in here. You may have a few other little random questions and stuff in there, but for the most part, I just wanted to hit the important stuff in chapter 1. So I'll let you out early. If you didn't get on the roster and you're here, let me know, because I can't, for some reason, can't see everybody at one time. And I think we got everybody, though. I wish they would just put them all on the side there. All right, but let's just see if anybody else ever showed up. The only people that weren't here was Justin Gobert and Kayla Jenkins. Are those folks out there? All right.